Hello friends, today we will be starting with next topic, that is influence line diagram. Short form we will be using the term ILD. First let us go into the basics. So far whatever you have studied, whatever structures you have studied, there were two types of loads. One load was dead load, means load which was acting because of the sections. Say this beam itself has some load, so that is dead load, that is fixed. Next is live load or applied load. So different types of loads are dead load, live load. So these loads, they are fixed, they act for a fixed span and for all the times. Hence whatever reactions, shear force and bending moment you get, they are constant, they are fixed. But if you look at some of the structures, say let us consider a bridge. Say I am having a bridge like this. There is one support here, second support here, third, fourth, like this. And let us assume that a vehicle tries to cross the bridge in this direction. Say that vehicle has two wheels, like this. When this tries to move along this bridge, there is variation of shear force, reaction and bending moments, because this load is not constant, it is moving. Hence we need to find out at what location and what are the maximum shear force, bending moment and reactions, so that we can design these sections safely. For that we use influence line diagram. Now influence line diagrams are nothing but diagrammatic variations, diagrammatic representation of variation of reactions, shear force and bending moment due to movement of unit load. Unit load means 1 kilonewton load. So influence line diagram are nothing but diagrammatic representation or graphical representation of variation of reactions, shear force and bending moment due to movement of unit load. It can also be defined as a curve or a graph that represents functions like reactions at the support, shear force and bending moment at a section for various positions of movement of load. So if this load moves from here till here, at any location, what is the shear force and bending moment it produces? So these are the loads. So these vehicle loads are, or wheel loads, these are the loads which vary or which change with time. Hence we use ILD, influence line diagram, for design of bridges, for design of flyovers, etc. Now these loads may act at most critical points, producing maximum effects. Maximum effects like maximum bending moment and maximum shear force. Hence understanding of maximum effect due to loads is important for design of the structures. Now there are various types of moving loads. Types of moving loads. First, single point load. Single point load is something like this. Say this is one bridge or a girder. A point load, only one point load is there and it moves from left to right. So this is called as single point load. Second is 2-point load. So instead of one, there are 2-point loads. Third, multiple point loads. Instead of 2, there might be 3, 4, 5 like this. Multiple number of point loads. Next case, it might be UDL shorter than span. Shorter than span is the case like this. Say this is one beam. Say its span is 5 meters and there is a UDL. Say that UDL is like this. Say its span is 3 meters. So span of the UDL is shorter than span of the beam. So UDL shorter than beam. Next case, UDL longer than span. So longer than span is the case like this. So this is this thing and my UDL is like this. Say its span is 5 meters, span of the beam is 5 and span of the UDL is 7. So span of the UDL is greater than span of the beam. So these are the various cases which you will be studying. Now let us note down some of the standard values. Let us consider a beam of span L. I want to find what is shear force and bending moment at point C. Let that point C be at a distance of x. So this distance is x by L. Now shear force diagram for this ILD is given by like this. This shear force diagram is positive, this is negative, and this value is L minus x by L, and this point is x by L. These are the values. So this is the shear force diagram, typical shear force diagram for the influence line diagram. Similarly, bending moment diagram. Now, this is the maximum bending moment. Moment at point A and point B are 0, and bending moment here is given by value x L minus x by L. Let this distance be x and this distance is L minus x. So you have to remember these two diagrams. This is for shear force, this is for bending moment at any given section. So next we'll take up a standard example. We'll conclude now. Thank you.